This is a review of the concepts from Chapter 3 from the Math 2101 book. So if you're not doing that book, then hopefully this is useful to you. If you are doing that book, then if you don't understand something that I'm talking about in this video, it means you need more time with Chapter 3. Get a bit more practice. Let's start with BEDMAS. BEDMAS is big in math. Now the first thing to say about BEDMAS is it's not always called that. Sometimes it's called PEDMAS. Sometimes it's called PEMDAS. And sometimes it's called BEMDAS. And I'm sure there are others. These are just acronyms that help us to remember the order of operations. When they're arranged in this way, it sort of forms a word, and you can remember the word. I use BEDMAS. I'll explain what the differences are. First of all, the B and the P, that's a big difference. B stands for bracket. We do brackets first when we have a bunch of things to do in an expression or an equation. E is exponent. That's an important one. It's common mistakes happen when people don't follow the rules of the order of operation when it comes to exponents, especially in geometry formulas. D is divide, M is multiply, A is add, and S is subtract. When people use PEDMAS instead with a P here, they mean the same thing. B is for bracket, P is for parentheses. They're really the same thing in math. So that's the only difference between the ones who say BEDMAS and the ones who say PEDMAS. What about this putting the M before the D thing? Well, that's an interesting little topic in itself. Divide, multiply. The way I'm teaching it, BEDMAS, it implies you would divide before you multiply, but it's not really true. Divide and multiply are actually in a tie. You don't have to divide first, you don't have to multiply first. So when you have more than one of them, which one do you do first? I do whichever one is further to the left first. Same thing happens over here with add and subtract. They're not really arranged that way because add has to be done before subtract. It's a tie. So when you have both adding and subtracting to do the leftmost one first. Interesting, you never see anyone put S before A in these acronyms, or I never have, but the DM thing gets switched back and forth. It doesn't matter. So the logic that you have when you're following this is I'm going to do my brackets, then I'm going to do my exponents. Then I'm going to do any divisions and multiplications I have, whichever one is to the left first. Then when they're all done, I'm going to do my adding and my subtracting, and I'm going to do whichever of those I have with the one that is further to the left first. That's the order of operations, and we're going to use the order of operations when we do examples. In fact, once we have encountered this in math, we're going to be using this forever, for as long as we ever do any math. Next thing I'm going to cover is a little perimeter problem. Let's make a nice simple situation. We have a rectangle. This side is 6, this side is 8. We know it's a rectangle because we're marking these little squares that show right angles at the corners. That means we know this other side is 6 over here. Opposite sides are equal in a rectangle, and that means this one's 8. We're asked for the perimeter. The perimeter can be found in two ways. We can either add the sides together, which would look like this, or we can use a little perimeter formula, which is 2 times length plus width, which will be 2 times 6 plus 8, which is 2 times 14, which of course gives the same answer. What's my unit of measure? There is none. They didn't give a unit of measure in the question. Well, most students will just say, okay, good, that means I don't have to put a unit of measure in my answer. And you don't have to. I'm not taking off marks if the student doesn't put the unit when the question didn't have units. I'm more impressed with someone leaving it with no unit than with someone who just invents one, like sticking centimeters there. Well, how do you know it's centimeters? I start wondering. I'm wondering what the student's thinking. But what I like to do is use the word units as my unit. Why? I started doing it when I was in secondary school, and teachers seemed to like it. It was just a way of being organized. I liked writing something, but there was a fringe benefit. And the fringe benefit will become obvious when I do my next example. So let's erase. I want to do an area formula. I'm going to do an area of a circle. So we have a circle. Its radius is 4. And we want to know the area. Area equals pi r squared. I'm using 3.14 for pi, so it's 3.14 times 4 squared. And oh look, we have to do BEDMAS. We have to do exponent before multiply, because the E in BEDMAS happens first before the M in BEDMAS. And that is the most common mistake I ever see students make, where they don't apply the rule of BEDMAS properly. So that means I keep the 3.14 where it is, and I do 4 squared, which is 4 times 4, which is 16. Then I multiply. So 3.14 times 16, 50.24 is my area. No unit was given. So I use units as my unit. No, I don't. It's area. I use units squared as my unit. Now we see the fringe benefit of being in the habit of using units as your unit when no unit was given. Because that way, when you get to an area question where you may have to, in order to earn full marks, prove you know that the units are square, it reminds you, oh, I wrote the word units, I better put a little 2 on it to prove that I know this is square units. That's why I like to do it, and that's why I like students to do it. How about volume of a sphere? Now, interestingly, this book isn't about geometry, but it sure is full of geometry. So the volume of a sphere formula is 4/3 pi r cubed. Look what I'm doing here. It's another habit that I'm in, which teachers always liked when I was a student, and I like it when students do it. V means volume, but in a problem where you have more than one shape, when you write V equals this, V equals that, it gets a little confusing. It's hard to read. It's hard for the teacher to read and find things when we're correcting you, but even worse, it's hard for you to read your own work. And when people have trouble reading their own work, they get confused and they make mistakes. So this is a way of being organized so that we can tell, oh, this is the volume of the sphere, not the volume of that other shape. And it's a good habit to be in. Pi is 3.14 again. My sphere has a radius of 2. So it's 2 cubed. BEDMAS, I don't want to multiply yet. 2 cubed is 8. I did my exponent first. Now I can multiply. 4/3 times 3.14 times 8 is equal to 33.5. I believe that is rounded. And of course, no unit was given. I don't see centimeters or meters or anything. So it's units cubed, because it's volume. So again, the fringe benefit. Being in the habit of putting the word units as your unit allows you to remember to stick that little 3 there so that you don't lose a mark, because volume units, of course, are cubed. Let's do one more, a cone. This cone has a radius of 5. It has a height of 8. I'm not going to involve the slant height. I'm going to keep this one simple. The volume of a cone is equal to pi r squared h over 3. And that gives me a moment when I say, huh? what's this? How does this fit into BEDMAS? Well, it fits in, and there's more than one way to show it, but the way I like to show it is, and I don't necessarily do this when I'm solving a volume of a cone problem in a math test, but the way I'm liking to show it now is to write it like this. It's one of the correct ways to show it, and then you can see, oh, okay, that's a division. And you know what to do, because you know where division fits in BEDMAS. So pi, again, is 3.14. The r squared is going to be 5 squared. The h is an 8. And then, oh, I got extra brackets here, so what I'll do is I'll use a square bracket and put the divided by 3. See how cute that is to use different styles of brackets so that you don't get confused when you're reading your own equation. BEDMAS, 5 squared is 25. Well, we're just racing to the end of this problem, aren't we? When we multiply the 3.14 by the 25 by the 8, we get 628. But we still have to divide by 3, because that's what we do in the volume of the cone formula. So we have an answer of 209.3. Again, that is rounded. And I'm writing units cubed, because it's a volume. Okay, that's enough for the geometry formulas for this review. Now we're going to make an equation out of a situation using variables, and the situation is we're at the drive-in movie theater, there's a bunch of us, and we go to the snack counter, there's a line, so we want to get organized so we know what to buy and get in and out of there quickly, get back to the car with our food. There are 5 of us in the car. 2 people want a hot dog and a juice. 3 people want a burger and a water. We also want some popcorn, and we're going to give a tip. There's a bunch of little things that we have to take care of to solve this problem. And how you do it is very flexible. A student can come up with a completely different strategy than the one I'm about to use to show all of the math for this situation, and they can still be right. But this chapter likes to show us how to build equations with certain type of variable, and that's what I'm going to do. First, I'm going to give the menu. The hot dog it costs $2. The burger costs $4. The juice is $1.50, the water is $1. Popcorn is $3. I've decided I'm going to give a $5 tip. Now let's make an equation. Well, we have to define variables. We kind of already started showing some variables, but I'll define them anyway. I'll say H equals hot dog. B is burger. J is juice. W is water. P is popcorn. I'm not going to use a variable for the tip. I'm going to make that a constant. And, oh, well, C will be the total cost. So my equation is going to be C equals, now there's more than one way of doing this. You can make a really long equation, or you can take advantage of the use of brackets to make the equation a little shorter. So 2 people want a hot dog and a juice. 2 becomes a numerical coefficient multiplied by a bracket, which is the cost of the hot dog plus the cost of the juice inside. 3 want a burger and a water. We've decided we're going to get 2 containers of popcorn, one for the front seat of the car and one for the back seat of the car. So we have just 2p, oops, need a plus. We have just 2p for the popcorn, And then the tip is our constant. We're making it a $5 tip. I don't really know what the total bill is going to be, and I'm not going to bother calculating a percentage. I've just decided I'm giving $5. So that's a constant term. So we have things we're already used to from earlier chapters like 2p plus 5. It's very similar to what we were doing in the other two chapters. But what's new is we're using brackets. And that's really what this example is about. So the total cost will be equal to 2 times hot dog plus juice, 2 plus 150, I'll write 150 as 1.5, plus 3 times burger plus water, that's 4 plus 1, plus 2 times the P for popcorn, which is 2 times 3, plus the 5. Well, we can finish this off now. But BEDMAS, bracket, you do bracket first. So even though this is a plus, and that's a multiply, and normally multiplies happen before plus, bracket forces us to do the plus first. So we keep the 2 where it is. 2 plus 1.5 is 3.5. I solve inside my bracket. I do that again over here. 4 plus 1 is 5. Tempting to just say 2 times 3 is 6 and write a 6 here, but no. This is a BEDMAS lesson. I want to follow the order of operations. Sometimes, if you do things a little out of order, you get away with it. But you don't want to just get away with things by luck. You want to be in control. So to be in control, you apply the rules of BEDMAS, and don't try any sneaky little tricks unless you have practiced them a lot and are really good at them. 2 times 3.5, now we can multiply, is 7. Can't do this plus yet. 3 times 5 is 15. 2 times 3 is 6. Now all we have are pluses. So I can follow the order of operations and say 7 plus 15 is 22. And then write another line, or I can do it all at once. They're all additions. Well, I'm going to do it fast all at once. 7 plus 15 is 22, plus 6 is 28, plus 5 is 33. It is going to cost $33, which includes the tip, to buy all of these snacks for our car full of people at the drive-in movie. So now we can see how the bracket comes into this style of equation, and how to solve things once we have put the bracket in there. And that covers, I think, all of the little concepts that come together to form chapter 3. So if you understood everything I said, that's great. If there's anything I said that you didn't understand, or that you just don't think you understand it very well, it sounds like you need more chapter 3. So get back into chapter 3 and do more practice.